So in this video we're going to be talking about reflection using the folding paper method. For this you're going to need a square paper and draw to scale. So we're given this diagram and the first question says determine the coordinates of Q if they are translated 3 units downwards and 4 units to the right. Okay, looking at this is our point Q with coordinates -5 and 4. So if they're translated 3 units downwards, that will be 1, 2, 3, meaning the value of y will then be 1. And the value of x and 4 units to the right, it will be 1, 2, 3, 4. So that will be -1. So Q will be -1 and 1. And the second question says, what will be the coordinates of point K if they're reflected about the x-axis? Okay, this is our x-axis. If we fold the paper in half, remember that this paper is square. Try to divide it where the line is. Okay, I tried to divide it to where the line is. And remember, we're looking for the coordinates of K if they're reflected about the x-axis. So fold the paper in half. This is our K. Try to give it a little rub so the ink stays on the other side. So this is our point K. As you can see, it reads -5, which is the y value, -3, which is the x value. So the coordinates of K after reflection will be -3 and -5. So the third question says, what will be the coordinates of point O if they're reflected about the y-axis? This is basically the same thing, only we are dividing about the y-axis. Okay, I think that's perfectly on the line. That's my fold. Remember, we're looking for point O reflected about the y-axis. This is our point O. When reflected about the y-axis, give that a little rub so the ink stays on the other side. So you can see not very much visible, but that's our point, which reads 4 and 2. Always 4 and 2 after reflection about the y-axis. Remember that was question 1, 2, and 3. The fourth question says, determine the coordinates of point N if they're reflected about the line y equal to x. Remember, the line y equal to x basically lies here. It's like you cut the whole Cartesian plane in half, but diagonally. This is our line y equal to x. Now you might be wondering why I made it like this instead of this. So it is because this line is positive, like y equal to x is positive this side. If they said make a reflection about the line y equal to negative x, then it was gonna be this side because x is negative on this side. But since they said the line y equal to x is positive on this side, hence we did this line on the other side. Remember, we are looking for the coordinates of point N. So let's try to fold. Okay, I tried to make the fold perfectly on the line. So since we're looking for the coordinates of N, let's do this. Here's our N. There it lies. So the coordinates reads 2 and negative 3. That's number 4. The coordinates of N are 2 and negative 3. So the last question says determine the coordinates of point P if they are reflected about the line y equal to x. It's basically the same line, only we're looking for a different point, which is P. So let's fold and repeat the same step. Here's where P lies. The coordinates read as follows: 3 and negative 5. The coordinates of P are 3 and negative 5 after reflection. I know this method may take up some time, but it's effective.